Good morning. Today we are going to discuss about petrology. Petrology is defined as the study of rocks. So it's actually a branch of geology which deals with the various aspects of rocks, how the sedimentary metamorphic rocks are formed, how they are classified and where they occur. So all these we discuss in this particular presentation. So the rocks, we know they are naturally occurring, solid, massive aggregates of minerals, and they form the crust of the earth. And on the basis of origin, we have igneous, sedimentary, and metamorphic rocks. And we know igneous means rocks are created when magma cools, and when the magma, that is a molten lava when it comes out on the surface and it cools and it becomes solid. So that is how igneous rocks are formed. Whereas sedimentary rocks, for example, sandstone, limestone, shale, conglomerate, gypsum, etc. So they are made of particles of sediments like sand, clay, then skeletons and shells of sea creatures, etc. Whereas metamorphic, that is marble, slate, quartzite, guineas, etc. These are metamorphic rocks and they are formed when the minerals in the rocks are changed. So their composition is changed, and this change in composition is due to a heat and pressure. So existing igneous and sedimentary rocks, they undergo a change and they form metamorphic rocks. Then igneous rocks. So this is actually a photograph showing the different types of igneous rocks. Granite, scoria, pumice stone, then they are examples of igneous rocks. Sandstone, limestone, shale, conglomerate, gypsum, examples of sedimentary, and marble, slate, quartzite, and gneiss are examples of metamorphic rocks. So these names you should know. Then igneous petrology. Another term is igneous petrology. So igneous petrology means it studies the identification, classification, origin, evolution, and process of formation and crystallization of igneous rocks. So here you can see a photograph showing all the different igneous rocks. Then we know due to tectonic movements of plates and due to loading, crustal loading from above, and there can be density differences, because in some areas that is oceanic crust. So above the oceanic floor there is a lot of a large depth of water. So the density of seawater, we know it is 1025 kilogram per meter cube only. Whereas in areas where above the plate there is soil or rock, so the density is high. So at the boundary you can see that there is one area it is subjected to very high pressure, another area comparatively less density. So these density differences, etc., all this can cause there can be the reason for the formation of these rocks. So hot molten material which is occurring below the surface of the earth is called magma. So magma is forced upwards. So due to all these movement of plates, there can be a diverging plates can lead to a small a fracture on the earth's crust, and through this fracture molten magma that will come up. Okay, it is forced upwards. So, and as the lava reaches the surface, it becomes magma, and through the crust along lines of weakness this will be flowing out. Then once it reaches the surface, it may start to cool down, and after cooling of lava, two types of igneous rocks are formed. Rocks which are formed on the surface, that we call as extrusive. So extrusive, like external or outward. So it is something which is lying on the outer surface, that is called as extrusive igneous rocks. And some of the magma, it did not find an outlet, and it may solidify in cavities and fissures within the crust. So that means there can be holes and cavities inside the earth crust. Okay. So inside the fissures or cavities, the magma will be trapped, and there it will lie for a long period. It will cool down there itself, and that rocks we call as intrusive type of igneous rocks. So igneous rock can be categorized into extrusive and intrusive. The rock formed beneath the earth's surface we call as intrusive, and slow cooling magma. The characteristics of intrusive igneous rocks, that is, we can see that intrusive igneous rocks, due to slow cooling, the mineral crystals are very large. So large crystals are coarse grained rock. Okay. Then coming to the primary or basic rocks, that is igneous rocks. So igneous rocks are considered to be the first form of rock, and they supply materials for other types of rocks. So these rock forms include more than one mineral deposit, and these may either be glassy or coarse in nature. And no fossil content is found in igneous rock. Why? Because due to this particular heat of the magma, these materials may get burnt away. Okay, so that is why fossil content is absent in igneous rock. Then this is another photograph which shows the different types of igneous rocks. Igneous rocks are also classified based on their depth of occurrence into volcanic, hypabyssal and plutonic rocks. Volcanic means they are formed on the surface. Okay, like we explained about extrusive rocks on the surface. So since the lava cools down at a very fast rate on the surface, the grain size of the crystals is very fine or microscopic. So fast cooling is a reason for the fine grained texture of volcanic rocks. Then hypabyssal, these are found at intermediate depths like 2 kilometers below the surface of the earth. Up to 2 kilometers. So from the surface of the earth up to 2 kilometers, that depth, the type of igneous rock found is called as hypabyssal rock. They exhibit mixed characteristics of volcanic and plutonic rocks. An example of this particular hypabyssal rock is porphyry. Then plutonic rock. So they are formed at considerably large depth, that is 7 to 10 kilometers below the surface of the earth. Due to very slow rate of cooling at these depths, so slowly only the magma or lava will cool. The rocks resulting from magma are coarse grained. Due to the erosion of overlying strata, sometimes after years, these rocks may get exposed on the surface. Examples of plutonic rocks are granite, syenite and gabbro. So volcanic, hypabyssal and plutonic are the three classifications, three types of based on the depth of occurrence. On the surface we call it as volcanic. So there, due to fast cooling or rapid cooling, it is fine grained texture. Hypabyssal, it is found from surface up to a depth of 2 kilometers, and it shows the characteristics of both volcanic and plutonic. Whereas in the third type, that is plutonic, it is found at a very large depth, that is 7 to 10 kilometers from the surface. Okay, 7 to 10 kilometers from the surface. And the cooling occurs at a very slow rate. So coarse grained texture, coarse grained rocks are formed. So plutonic rocks are mainly coarse grained, and examples are granite, syenite and gabbro. Okay. Next we are going to study about the chemical composition. Mainly it contains SiO2, 59%, nearly 60% silica, 15% alumina and remaining calcium oxide, magnesium oxide, oxides of sodium, potassium, water, etc. And the mineralogical composition, it has feldspar, that is a major group, and pyroxene and amphiboles, that is found in 16%. Then remaining quartz, biotite, titanium and apatite. Then the texture of igneous rocks. So texture is actually mutual relationship of different mineralogical constituents in a rock. It is determined by the size, shape and arrangement of the constituents within the body of the rock. Mainly this texture is actually a factor or a main criteria which affects the texture is the crystallization, whether it is slow cooling or rapid cooling. Like the degree of crystallization, granularity, the type of granules and the type of fabric. So all these are the determining factors for the texture of igneous rocks. Now, depending on the degree of crystallization, the texture can be of different types. First one is hollow crystalline, or it is called as pheneric. When all the constituent minerals are distinctly crystallized, that is very well defined and distinct and clear. Okay, that is called as hollow crystalline or pheneric. Then hollow hyaline or affinitic. Hollow hyaline or affinitic. Here, all the constituents are very fine in size and glassy or non-crystalline in nature. Then merocrystalline or intermediate type. Some minerals are crystallized and others are of glassy character in the same rock. And microcrystalline, that is, the minerals are perceivably crystallized, but it is visible but extremely fine grained. Then next important term is granularity. So it defines the grain size of various components of a rock. The average dimensions of different constituent minerals are taken into account and describe the grain size of a rock as a whole. So if the size of the grain is above 5 millimeter, then the minerals are easily identifiable with our naked eye itself. So that we call as coarse grained. And if the grain size lies between 5 millimeter and 1 millimeter, you may require a magnifying lens and in order to identify the different constituent minerals of a rock. Then we call it as a medium grained. Then if the average grain size is less than 1 millimeter, we may require a microscope, and that is called as a fine grained. So we have discussed about the degree of crystallization. So based on that, hollow crystalline, hollow hyaline, merocrystalline and microcrystalline. And based on granularity, we have coarse grained, fine, medium grained and fine grained. Now next is the fabric. Okay. So fabric is actually the relative grain size of different mineral constituents in a rock, as well as the degree of perfection in the form of crystals of individual minerals. So based on the fabric, again we can classify into 3: panidiomorphic, hippediomorphic and allotriomorphic. Panidiomorphic means when majority of the components are in fully developed shape. Hippediomorphic, the rock contains crystals of all categories, that is euhedral crystals, that is perfect crystals are there, subhedral or semi-perfect are there, and anhedral, totally irregular. So all these are present, then we call as hippediomorphic. Allotriomorphic is when most of the crystals are of anhedral or of irregular shape. So fabric, we have 3 types, that is panidiomorphic, hippediomorphic and allotriomorphic. Then the certain special features of igneous rocks. Here you can see felsic and mafic. So magnesium and iron, that is mafic. So examples are obsidian, basalt, gabbro. Then felsic we have pumice and granite. Then fine grained and coarse grained, you can see felsic mostly rhyolite, granite, etc. And so as the silica content increases, it becomes felsic. And mafic, that is basalt, gabbro, etc. And andesite, diorite, they are having in between this mafic and felsic. Next is based on the composition of the minerals. Based on the rate of cooling of lava, granular size of rocks was dependent, and for very fast cooling and size of granular becomes smaller, whereas slow cooling it becomes larger. So when we have discussed about the uh, volcanic hypabasal and uh, uh, different types of rock based on the depth of origin we have discussed. Okay, so that is the classification of igneous rocks based on the depth. Okay, so there we have this different categories, that is volcanic, hypabasal and plutonic. Plutonic means that is occurring at very large depth, that is 7 to 10 kilometer. Okay, so similar to that, here also we have different classifications. That is on the surface we know the rate of cooling is very rapid, so the crystals are very fine grained, whereas in the case of plutonic, that is very large depth from the surface, so it's very slow cooling. As a result, it is coarse grained texture. So same thing here, it is repeating. So this we have already discussed in the case of classification based on depth of occurrence of igneous rocks. Now, based on chemical and mineral composition of igneous rocks, some different types are there. Mafic or basic means it contains 44 to 52% of silica. Okay, and gabbro, basalt, dolerite, etc. are example, and it is denser and dark in color, these mafic or basic rocks, whereas we have ultra basic or ultra mafic rocks. So there the silica content is less, only 44%, and example is peridotite. Then siliceous rock. Silicic rock means rock contain more than 66% of silica, for example granite, granodiorite, etc. And this type of rock is less dense and lighter in color. Intermediate rock contains 52 to 66% of silica in nature, for example andesite, diorite, etc. And this type is also less dense and lighter in color. So this is actually so you can see fine and coarse, felsic, intermediate, mafic and ultra mafic. So these intermediate rocks are less dense and light in color, whereas these mafic rocks, they are dense and dark in color. And ultra mafic means again the content of silica is about 44%, and silica that is which contain high percent of silica, that is about 66%. Okay, so again here also you can see that how the darkness and specific gravity increase as you go towards the right. Okay, felsic, intermediate mafic and ultra mafic, and also when you move towards the right, the silica content is actually decreasing. Okay, so for ultra mafic we know the silica content is only 44%, whereas the high content of silica is available for high content of silica, that is more than 66% of silica is available for silicic type of rocks, and 52 to 66, that is intermediate rock, and about 44 to 52% for this mafic. Okay, 44 to 52 for mafic, then 44% for ultra mafic, and intermediate you can see which is 52 to 66, and also this felsic and yeah. So in the bottom it is showing, yes, when you move towards the left you can see the silica content is increasing, yes, and if you move towards the right you can see the darkness and specific gravity also it is increasing. Now classification of igneous rocks based on the texture. First one is equigranular. If the majority of the constituent crystals are broadly equal in size, we call it as equigranular, and the majority of constituent minerals show marked difference in their relative grain size, we call it as inequigranular texture. Then next, type of texture is called as the porphyritic, that means large type of large sized crystals or phenocrysts are embedded in fine grained texture. So conspicuously means very clearly, you can see that very clearly big sized crystals, that is called as phenocrysts, and they are embedded in a fine grained matrix. So the matrix is fine in that large sized crystals. That can be, the reason can be difference in the molecular concentration or change in the physico-chemical conditions and relative insolubility. Some mineral constituents may be relatively insoluble in magma. So they will be there as such. They will not be soluble. So they will retain their texture as such. So here you can see those leaf-shaped big big light brown colored big phenocryst. Okay, phenocrysts are present, and the remaining matrix, that black and white matrix, is fine grained. So this is a example of porphyritic texture. Big large sized crystals called phenocrysts are embedded in a fine grained texture. Next is poikilotic. Here you can see that presence of fine grained crystals within the body of large sized crystal. So here the majority of the crystals are large grained. So in that you can see fine grained texture. Then next is directive texture. This indicates the result of flow of magma. Okay, flow of magma during the formation of rock. Different types are trachytic and trachytoid, parallel arrangement of feldspar crystals and non-parallel arrangement. And this is due to mobility of magma, that is we have flow structure, pillow structure, ropey and blocky lava, and we have spherulitic structure is there, and orbicular structure is also there. So first one is, so all these are simply shows the direction of magma flow. So nearly parallel, that is flow structure, and pillow like bulbous overlapping pillow like, and ropey and blocky lava means, as you can see here, there are these are the variations developed in volcanic rocks due to different mobility. Highly viscous means what? It has high resistance to flow. It is, the lava is very dry and lava is moving at a very slow rate. Okay, so it undergo very little movement after eruption. It is slightly moving, it's very sluggish. Okay, so the surfaces show broken and fragmented appearance, and that is called as blocky lava. Lava having low viscosity, that means low viscosity means it flows at a higher speed. Okay, velocity is more, so it can flow with a great speed for considerable distance, and then the upper surface will be smoothly wrinkled, and that is how ropey lava develops. So blocky lava develops when the lava is having high viscosity, that is resistance to flow. It is moving slowly, okay, slow velocity, and ropey lava is developed when the lava is moving with low viscosity. Okay, that is high velocity. Next is spherulitic structure. Okay, spherulitic structure means it is distinguished by the presence of thin mineral fibers of various sizes, that is arranged in perfect or semi-perfect radial manner about a common center. An orbicular structure means composed of ball-like aggregations. You can see in the photograph. Then we have different structures based on the jointing, sheet and columnar. Sheet means horizontal set of joints closely spaced and dividing the rock into sheets, and columnar like columns. Vesicular means the lava which may be rich in gas at some time. Okay, and these gas during the cooling and crystallization, these gas escape and it leads to the formation of cavities of various size and shapes. So that is called as vesicular structure. So again, this is a photograph showing the different textures of igneous rock, which I have already discussed. Then coming to the sedimentary petrology, here we studies the process of transportation and deposition of sediments. So about 70% of the rocks in the Earth's crust are sedimentary rocks, and weathered materials are transported and deposited, and they converted into consolidated rocks by cementation, and that is called as lithification. Fossils are generally, so in igneous rocks we said fossils are absent, whereas in sedimentary rocks fossils, that is dead organic matter, or their remainings of organic beings. So that is generally found in this type of rocks, and the maximum sedimentary rocks are found in shale, sandstone, limestone, etc., and they can be classified into mechanically, chemically, organic. Mechanical means clastic, then shale, clay rocks, etc. Chemically formed gypsum, salt rock, and organically formed coal, peat, limestone, etc. Mechanical due to the physical process operating at the time of deposition of sediments. Chemical due to chemical process like evaporation, precipitation, and crystallization. And organic which develop due to the manner in which the organic source materials get accumulated and compacted to form a rock. And stratification is another important characteristics of this. Layered arrangement and lamination or thin layers. Cross-bedding, layers lying one above the other. They bear an irregular or inclined relationship to other. Tabular, like top and bottom surface are parallel. Lenticular, that is each layer is intersected by many other layers lying at different angles, and wedge shaped. Then graded bedding is there, that is coarse at the top and fine at top, coarse at bottom. So at the bottom you can see large sized coarse grained and fine grains at the top. Mud cracks, that is polygonal or irregular cracks along the surface of the rock. Rain prints may be there, ripple marks due to the wave and wind action during the process of deposition. So again here you can see graded bedding, and also you can see these mud cracks. Here you can see polygonal or irregular shaped cracks are being formed along the surface, and also in the photograph you can see rain prints, and the second one you can see ripple marks. Okay, so next is the chemical. It is concretionary, nodular, and geode. So concretionary means rounded, subrounded, rough or smooth concretions. Oolitic and pisolithic. Oolitic means the size of the concretions, they are very 0.1 to 1 millimeter, very small. Whereas pisolithic means the individual size of a concretion is like that of a peanut. So these the first figure, the figure on the left shows oolitic type of concretionary structure, and the figure on the right shows pisolithic. Okay, you can see peanut shaped or size like that of a peanut. That type of concretions are being shown. Next is nodular. It is seen in limestone. It is differentiated by the development of irregularly shaped nodules of iron oxide, chert, iron carbonate, etc. And next is geode, a hollow shell of rock. Interior is lined with inwardly projecting crystals. So that is a geode. And next is organic structure, fossiliferous and stromatolithic. So fossiliferous structure means presence of fossils of plants or animals in the rock. And stromatolithic means it is produced by the presence of remains of algae. Okay. So these are the different structures of sedimentary rocks. Okay, thank you.